the new stuff. Some people are saying that, you know, it's more about the aerosol. So, you know, the moment you take it off, we're inside a building and it's like, oh, who knows? I'm still going to wear them. I blame the flat earthers.
Hey, you know what? There's another group of people who believe that germs don't exist. You simply get it.
You get it from what?
You get it because you look at it. It is a twisted theory.
What? You look at the germ and then.
No, like if somebody's sick and you look at them and you get sick.
Oh, you looked at the person.
For example, there's this guy who went out and shot a deer, okay? And he got pink eye. Well, apparently the deer had pink eye, which gave him pink eye, and then the family never even seen the deer, or it was like a different family that never even seen the deer in person or seen him, but they got pink eye. And the reason they got pink eye is because they looked at a picture of the deer.
Oh my gosh, I love all of that.
I know, it's so
How
entertaining.
did you know these people?
No.
Oh my god.
Is that another person your dad works with? No. Just I don't know. Some people, I don't understand how you can like convince yourself of that works. Yeah.
So bizarre.
All right. Now, I'm going to tell you that El Nino is a complicated thing. And it looks as if we're not on track to be in an upcoming El Nino year, but we were last year. Okay, we're going to talk about what that means for us in Indiana. Okay, but once again, from the video yesterday, it's all about a shift in the weather patterns, but only in one place, and that is in the tropical Pacific Ocean. Okay, now you like that 100% will be on like that question and that answer will be in the multiple choice on the APE exam. A tropical Pacific Ocean, not the Pacific Ocean, just in general, right? Because when we talk about that, oh, dang, okay, you know, we're doing this North Pacific up here. We're talking about the tropics, okay? So in this south and then over here as well, okay? That's where all the weather patterns, you know, are happening. Oh, quit. Oh, I didn't break my foot. All right, okay. All right, so that's where it's happening. And to give you that visual again from yesterday's video from Conrad. Okay, let's go here to this. Okay. Oh, that was weird. I just got right to it. That was creepy.
Some estimates blame that.
A little bit more. There you go. That's where it's all happening. Okay, you see we're you know off the coast of South America. Okay, boom. There we go. All right, now. So a long time ago, I'm like, how in the world do I ever teach anything about El Nino, let alone understand it myself? And I went to a conference, and I think it was the American Meteorological Society was presenting this stuff, and you could buy these cards, okay? So they're like this big, and they had like this little like pull tab, and you pull it out, and it changed like the windows inside the card, okay? And they were trying to sell them, and then actually the presenter was like, they're really expensive. We'd love to, you know, help you out here. So we're going to give you photocopied sheets of the cards. It's not as great as the card, okay, but they're photocopied sheets of the card. And I was stoked about it because for the first time in my life, I was like, I kind of understand El Nino a little bit more, okay? But it's not as cool as me passing out these cards. So you have 3 PDFs here, and they're really crappy PDFs, I'm sorry. But let me explain what's happening, okay? So there's a big giant picture in the middle, Okay, and you can, if you're all looking at this, you don't have to look at the screen, but you can look at your own. Go to the one that says long-term average. It's number 1 on your PDF. Okay, and do you see where it says long-term average? It's right there under the picture. Okay, then at the top, there's rainfall, surface air pressure, trade winds. Notice there's arrows pointing to, in this case, would be the west. Okay. Then we've got surface currents, sea surface temperature, sea surface height, and thermocline depth. Okay, I'll define all of those. Okay, but this is long-term average conditions. Now go to the next one and notice I've highlighted things in red. Okay, that's where you would pull this tab. You see this little thing that says hold here. You'd pull this tab and it would show you how it changes. So the non-red marks are the long-term average conditions. The red marks are, in this case, El Nino. Okay, y'all with me on this? So this is comparing like long-term average conditions with what's happening in El Nino, okay, in the west, in the central, and then in the east, okay? All right, you all with me on that? Does this make sense? Then if you clicked it, you guys, you want to open this up on your Chromebooks? Sorry, everyone else has your Chromebooks. You don't want to? You don't have to. Okay, you could look at it fine. Yeah, you don't have to. And then here's La Nina. We'll talk about this. So let's just look at the pictures first of all. You can see like there's some clouds right, on one end. Okay, it's kind of sunny on the other end. Okay, got a little bit of upwelling right here. Okay, if you look at El Nino, okay, there's no upwelling and the storms have shifted, right? Okay, from the west to the east. So to explain this before we kind of get into the activity, everybody point north. Okay, now point south. Now point east. Now point west. Okay, good. All right. So in this case, here we've got north, south, okay, east, west, right? In the picture. Everybody with me on that? Okay. So I'm going to be running around a lot. Let me see if I can get this on the camera. Mags, I'll try to do my best to get all this in, and hopefully this makes sense. All right. So when I run over here, where am I at? Okay, east. If I run over on this side of the room, hi. Okay, I'm in the west, right? Okay, I'll with you on this. Actually, can I carry this camera with me? I'll think about this in a second. All right. So let's go to north. What do you think long-term average conditions mean? What do you think that means? Yeah. But what's that even mean, though?
Oh, probably long term.
Okay. Yep. Good. Wow. It's a way to restate exactly what Tarina said. So what's long-term average conditions?
Like the weather and all that fun stuff over like a period, like a bunch of years.
Yeah, for sure. Okay.
Long-term conditions
On average, wow. I like how you switched some words around. So you're all right, but for these purposes, what's long-term average conditions?
like common kind of like
Yeah, so the most common, or when things are normal and not when things are going through what? El Nino, right? Okay. So right now we would be considered long-term average conditions. Y'all with me on this? Okay, because we're not in an El Nino year at this point, right? Yeah, your mom is too. All right. So yes.
So you said last year was there El Nino?
Yeah.
Or was it
Yeah.
just starting?
No, it was like, so it always happens in the winter. That's that whole like the child sort of thing. Well, in the southern hemisphere, it'd be the summer, right?
Like a time lapse, like this, like you could like watch.
Yeah. From this last year.
I want to watch.
Oh yeah, we'll do that.
Make more sense.
Yeah, we'll do that. Let me explain it, and then we'll see it. Okay. I have no idea.
Just read the farmer's.
I don't know. Yeah.
Yeah.
Farmer's Almanac can tell you.
Always right.
All right. Now look, in long-term average conditions, okay, right? This is where the storms are happening. Are the storms happening over here in the east, or are the storms happening way over here in the west? They're in the west. Okay. So as you're looking at this sort of thing, all of those clouds are happening in the west. Why are all the things happening why is the weather going to the west and not to the eastern tropical Pacific? Yes. Jesus. No, not Jesus. Okay. Why do you think the weather's, oh yeah. Nice guess. That's a great guess. We were talking about that in, the differences. Nope. There's a real obvious answer. If you look on this picture, Bringo. Nice. Okay. So if I'm the wind, right? Okay. I'm the wind. By the way, that's west, Mags. Okay. This is east. So when you see me running, okay, if I'm the wind, I'm pushing everything that way, right? Okay. That's why the trade winds are going to the west. So boom, 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 that's where all the weather's happening. If the trade winds are going that way, it's all because of pressure. Yeah.
Real quick, what exactly is trade winds? Not like the main wind stream or something?
Like the jet streams? No. Let's see.
The trade part of it?
Yeah. I think they call them the trade winds because of it used to be like how you would like share goods. You jump on those trade winds. Does that make sense?
Yeah.
All right. So things always, if you guys remember this from, if you took my anatomy class, then hopefully you remember that things like to move from a high pressure to a low pressure. Okay. If you took biology 1, which all of you did, okay, you all hopefully remember like that idea of hypertonic and hypotonic. Do you remember this? Does that kind of bring in AP Bio? You would talk to this too. If you took my freshman class, we took dialysis tube and we filled it up with water, okay, and then we filled up a beaker with sugar and we measured. You did that last year, okay? AP Bio, you measured the dialysis tube because the sugar would not go through the tiny pores, that semi-permeable membrane, right? So the sugar was too big, so only the water goes through, right? So if the bag had sugar water in it, okay, and the beaker had 100% of water, the bag would swell because the water concentration is higher in the beaker, lower in the bag, and water moves in because things like to move from a high concentration to a low concentration. Right. In your lungs, remember my lungs? Okay. The air goes in my trachea down into my bronchi, my bronchioles to my alveoli. Those alveoli are surrounded by capillaries. Oxygen moves out of your alveoli into your capillaries. But then carbon dioxide moves from your capillaries into your alveoli because of those concentration levels. Does this all make sense?
No.
Okay. No, not that part. Do you get the dialysis tube part though? Just remember high to low, right? Okay. What's the concentration of farts in my butt right now?
High.
Very high. I had beans for breakfast, and yes, extremely high. Like I'm afraid if I bend over, it might slip out. Right?
That's where I'm at right now too.
Okay, right. Okay, good. So what's the concentration of my farts in this room right now? Low, very low, right? If maybe we should mask up for this. No, I'm just kidding. But if I were to happen to just kind of like bend over, this actually happened to me. True story. And like it was Brooklyn Howard. She was sitting right here, and there was a paper on the floor, and I went to pick it up, and a little fart like popped out. Okay. Yeah, and then she and I both looked at each other, and she was like, and I was like, sorry. And then we just both start laughing. And everyone's like, what are you laughing at? It's like, I just farted. Okay, so if I did bend over and rip one right now, okay, things are gonna go from the highness in my butt to the lowness out here, and eventually, you know, who's gonna smell it first? Aries. Yeah, Aries in the hand there, maybe Halleck, maybe the smeller's the feller, right? You know, hopefully it would get out to the outskirts of you eventually, right? Okay, right, that would be the goal. The same is happening for our weather here. Okay, so I'm in the east, I'm going to the west because these trade winds are pushing everything. The pressure's high.
So that's the
Okay.
answer to number 11 about why Iowa.
That's true.
Yeah, jet stream. Typically the winds are moving from the west to the east. Not always though, because we know that that's not. So okay, y'all get this. Rainfall is high. Okay. The surface pressure is low because the pressure's high to low. That's forcing the winds this way. Do you all understand that? Okay. So far, so good. So it's sunny in the east. And Mags, I know I'm kind of moving this camera around. I'm right now, I'm looking at the picture. Okay. Can you follow me? Are you following me okay so far? Okay, cool. All right. So it's sunny in here because this pressure is pushing all the storms over here. And therefore the surface currents are also moving that way. Okay. The wind doesn't just, you know, you've all been to a lake, right? On a windy day and a calm day, right? There's waves in it's choppy. Why is it choppy? That's my uncle saying, you know, the lake's real choppy today. It's like, why is it so choppy? It's the wind's pushing that, right? Y'all with me on this? Okay, so if the wind is in the east, then it's constantly pushing everything to the west. So storms are in the west, then all the waves are over there too. So sea surface height is higher over there, okay? And also sea surface temperature is higher over there. Okay, think about our terms earlier. If I'm pushing everything this way, and then in the west, I'm going all the way west, okay, it's going to be more water, okay, more storms, because this water is warmer. What happens to water when it's warm? It evaporates. And then what happens to it?
It
Condenses and precipitates, right? Okay, so that warmer weather is creating more storms in the west. Okay, now the thermocline, and I wanted to say the definition. We'll get to this in just a second. Hold on a minute. Where is this number here? All right. So this is number 6 on page 6. You don't have to go to this, but I want to make sure that you see this. Okay. So the thermocline, because this is the newest maybe term for you. It's the thermocline is the transition zone between the warm surface water and the cold deep water. Okay, so think of cline as like a level, and thermo, of course, being temperature. And I think we've all had this experience before where we dive down in the water, like in the summertime, and it's really warm on top, but as you go deeper, it gets colder, right? And sometimes in like the spring, that thermocline is very shallow, right? Which means you jump in and it's not even like maybe warm for like a second, and then boom, you go down, it's like freezing. Then as that water heats up, right, it gets more warmth, so it's a little deeper thermocline. Does that make sense, folks? Okay, right? So in this case, all right, for this area, notice the difference in the thermocline, and it's hard to see on this board, but you can see these two words, shallow and deep. Okay, it's a shallow thermocline in the east because of this sun warming up the water. Okay, right? Even though it's a low sea surface temperature, it's going to be warmer, deeper. Okay, and then the thermocline is, it's going to be shallow here. Okay, because all the warm water is being pushed this way. Sorry, I messed that up. All right, so this is the long-term average conditions. East over here, storms pushing. It's going to be deeper over there. Okay, it's going to be hotter water. There's going to be way more storms. Okay, right, and that's closer to like Australia. Okay, and we have that dotted line with the equator. Y'all with me on that? Okay, so now what I want you to do, I want to see if you can figure this out yourself, and then we'll talk about it together. Okay, let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 together, so you understand what's happening. Okay, and then I'm going to ask that you can talk to your neighbors about doing 11 through 17. Okay, so the idea here is that they just put words, okay, to the stuff that I just told you. All right, so let's look at the window, and then let's also answer these questions together. It says, look at the large window. It displays a schematic of the Pacific Ocean along the equator, greatly exaggerated in the vertical. The scene depicts the ocean surface with atmosphere above and vertical cross-section of the ocean below. Fair weather appears in the eastern tropical Pacific, while, what are we going to circle there? Stormy weather, right, prevails in the western tropical Pacific. Okay, so everybody circle stormy in number 1. Okay, number 2, small windows depict conditions in the western, central, and eastern portions of the tropical Pacific. Dark blue triangles below the atmospheric windows and above the ocean windows point to the locations in the large window where conditions portrayed in the small windows are observed. That's, if we had those cards, that would be great. The windows to your left represent a location in the western, right? So west over here, north, south, east, west, the western tropical Pacific. Good, so circle western. Number 3, the arrows in the trade winds windows point in the direction which the prevailing winds are blowing. The lengths of the arrows denote relative wind speeds. The longer the arrow, the greater the wind speed. As indicated in the windows, winds during long-term average conditions blow towards the west, right? Good. And the wind speed, is it higher or lower in the eastern? What do you think? Okay, it's higher, right? Okay, why is it higher? Yeah, I said so, but also if you look, this is a little bit longer arrow. You see that longer arrow? Not by much, but if you see it on your computer.
Like stronger and easy because like the pressure is different.
I think it's just such a high pressure, yeah, and then it dies as it goes on. Great question. The smaller windows below the large window provide ocean information. Arrows in the surface currents window indicate that during long-term average conditions, surface water flows towards the west. Are you seeing a pattern here? Long-term, a lot of west, right? So according to the values reported in the windows, the highest sea surface temperatures, and we do abbreviate that SSTs, during long-term average conditions occur where? Western tropical Pacific, yep. This sea surface temperature pattern is caused by relatively strong trade winds pushing sun-warmed surface water westward, as evidenced by the direction of surface currents. Okay, strong trade winds also cause the warm surface waters to pile up in the western tropical Pacific so that sea surface height is higher than in the eastern Pacific. Transport of surface waters to the west also causes the thermocline. Once again, that's that transition zone. Is it going to be deeper or shallower, okay, in the eastern compared, yeah, shallower in the eastern. So shallower in the eastern. Number 7, warm surface water transported by the wind away from South American coast is replaced by cold water rising from below in a process called upwelling. We learned about that in our video yesterday. Upwelling of cold water results in relatively, what do you think? Yeah, so low sea surface temperatures in the eastern. So we're bringing up that cold water, okay? Cold water's coming up, even though it's sunny over here in the eastern, we're bringing up some of that cold water, okay? And also nutrients, bring up some of those nutrients. Okay, number 9, whenever air pressure changes over, wait, did I skip one? Oh, sorry. Cold surface water cools the air above it, which leads to the increase in surface air pressure. Warm surface water adds heat and water vapor to the atmosphere, lowering the surface air pressure. There's another answer for your air pressure there too. As shown in the surface air pressure windows, these effects result in tropical air pressure being higher or lower in the eastern. Highest in the eastern and lowest in the western, right? Because all my storms are they're going west. Okay? Whenever air pressure changes over distance, a force will act on air to move it from where the air pressure is high to where air pressure is low. The trade winds blow from east to west because from east to west, the surface air pressure decreases. Good. It's decreasing over time. Okay. Number 10, rainfall in the tropical Pacific is also related to sea surface temperature patterns. There are reasons for this relationship. The higher the sea surface temperature, the greater the rate of evaporation of seawater, and the more vigorous is atmospheric convection. Consequently, during long-term average conditions, rainfall is greatest in the western Pacific, where sea surface temperatures are highest, right? Okay, so I would like for you to try to do the rest of this, and you can talk to each other if you want. You could do it by yourself if you want, okay? But you'll use the next window, that's page 2 of the PDF, okay? So I guess you will need to stop here, okay? For the El Nino, and then the third PDF for La Nina, okay? And I want to see how far we can get. This isn't homework. What time are we out of here? I always forget. 10:22. Just see if you can get El Nino done. It's just 11, 12, 13, 14. We have 8 minutes. Just see if you can do El Nino real quick. That would be great. That's page number 2. And you can see it says El Nino right here. And I'm going to look up that video for you as well. And Mags, if you want to just do it on your own, and then I'll tell you the answers here in a few. Is that cool? Great.
Yeah, because it says, yeah.
Here's a little video, by the way, of right now up to September 16th. Notice that here's Australia. Okay, so by looking at this sea surface temperatures, can you all tell that it's all happening in the western tropical Pacific? See if I can go back to historical.
The red is from it's lower. On 100. It's lower. The red is highlighted. It's low. In the west. Oh wait.
The red is higher than the Disney.
No, it's not.
It says higher than to the west, and it says in the west. And then in the central Pacific, it's 10 below, but it's just the opposite of the same.
Did you change the tune?
Yeah, I changed it. It's higher.
Okay, can you show me what it's talking about? Yeah, it looks lower than that. Okay, so this is the west. So this is
I just
the
didn't read it
Delaware.
right. Sir, but no one can see everything you're doing on your screen.
That's okay. Thanks for telling me though. I appreciate that. Did you see that email I just sent about you?
Yeah.
Hey, by the way, thanks for asking me before you submitted my name. I refused to do that.
Yeah, I asked you at the beginning of the year if I could use you as one.
I don't recall that because I would have said no. I said yes.
Yes, and you gave me your number for it.
Gosh dang it.
I know. You're also on my resume.
Oh, you want me to say good things?
I know. It's hard to say good things about me. Did it send you like an email to let you know?
Yeah. I will get on that. How we doing? I like hearing the conversations, the arguments.
My chances of getting in the early were so low. I really want. Yeah, no, no, no. Yeah, I got higher. Yeah, baby. Let me look. Not sure. Elijah, hey, I was thinking if you get shallow or deeper.
I'm not there yet.
I got shallow.
I was trying to figure out.
What the frick?
Are you getting it, or do you understand what you're doing? No, okay. Do you want?
They said it's deeper. Well, because I circled deeper.
Should I have said maybe we should use a pencil on this?
Yeah.
Yeah,
Well,
sorry.
it's just like, I can't freaking read the stupid windows, because I don't know if it's like the red.
So
thing
the red is the new thing. The dark is the old thing.
Okay, so if the red is like highlighted on a black thing, like
If the
that's
red is highlighted on the black, so
Okay.
so compare it with the black mark.
okay.
Does that make sense?
Yeah. It's deeper.
But you might have to compare it with other red things too, right? So you're it depends on what it's asking.
It's thermoclimate or whatever. Thermocline. It's not shallow. What the heck? It's deeper.
The diagram.
The diagram says it's deeper.
All right, bring these back with you tomorrow. Okay, give you a little bit more time to talk. I like the conversation. It makes me happy. Okay, and then we will.
It's in the eastern. You're looking in the eastern part on the thermocline depth.
All right, Mags, we'll talk more about this tomorrow. Any other questions from you?
Right, it's deeper. Thank you.
Okay, great. See you later.